Hi, in this video, we'll be dealing with an important topic which we now call trigonometry. So we're going to look at trigonometry. So we're going to look at the very important concepts there. So we're going to look at the tangent of an angle. We're going to look at the sine of an angle, and we're going to look at the cosine of an angle. So supposing we have a triangle, as you can see, this triangle is what we call a right angle triangle. So a right angle triangle is a triangle with one of the angles equals to 90 degrees. So what it means is that here is a 90 degrees, and that's what we mean by a right angle triangle. So we are going to work with this kind of triangle in deriving this sine, the cosine, and the tangent. Now, what follows is that the sine, the tangent, and the cosine will be with respect to this angle. So we are going to make reference to this angle theta. But before then, we look at the names of the sides of this triangle. So this side, the side that is facing the right angle, is this side, and we call it the hypotenuse. And this hypotenuse is also known as the longest side. Then the side that is opposite to this angle theta. So if you look at this angle theta, this is the side that is opposite to it. So that side that is opposite to angle theta is what we now refer as the opposite. So we call this place opposite. Then the other remaining sides, the remaining side now is what we now refer as the adjacent. So this is what we have. So the next thing to look at now is to look at the tangent of theta, the sine of theta, and the cosine of theta. Okay, when that is done, we're going to have that tan theta now. Like we said, we are making reference to the angle. So we are working with tan theta. So tan theta we denote as the opposite over adjacent. So tan theta is always opposite over adjacent. So we use these small notations to represent opposite. So this is opposite over adjacent. Then we also look at sine theta. So sine theta will now give us opposite over hypotenuse. And finally, for you to find cosine, we can write as cos. Cos is the same thing as cosine, which will now give us adjacent over hypotenuse. So we have adjacent over hypotenuse. Okay. Then one more thing to note is that the theta is just like a variable, so we can also use x to denote theta. So I can use x, I can use any other value to denote, or any other symbol to denote theta. So theta, the symbol theta is not fixed. Then another thing to note also is we can also be given some other triangles. For instance, if I decide to change the position of theta, maybe I have, let's say I have theta here. Okay, supposing I have theta here, for instance, that means that this place now will no longer be adjacent. Like we said, the side that is facing the angle will become opposite. So if our theta is here, that means that here could be opposite. But when working with examples, we are going to see where we take different positions of theta. But for this particular case, we allow theta to be in this position. So in the next videos, we'll be looking at examples how to evaluate the tangent of an angle, the sine of an angle, and cosine of an angle. So we want to solve this example. We are given the figure below. We want to find sine theta, and cos theta. So we start with our formula. So we look at tan theta. So remember that tan theta is the same thing as opposite over adjacent. Remember, the opposite we are talking about is opposite to angle theta. So now, the side that is opposite to angle theta is this side, and the value there is 4 units. So we have 4. Now, over the adjacent. Remember the adjacent? The adjacent is here. So the adjacent is 3. So we can now say that tan theta is equals to 4 over 3. So the next thing is to look at sine theta. Sine theta is opposite over hypotenuse. And here again, the opposite to the angle is the same thing. To angle theta is the same thing as 4. So we have 4. Then hypotenuse is the longest side, which is the side facing the right angle triangle, which is 5 now. So we now have that sine theta is 4/5. And finally, we look at cos theta. Cos theta is adjacent over hypotenuse. So again, our adjacent is given as 3. So our adjacent is 3. So this will be equal to 3. Then our hypotenuse is the longest side, which is given as 5. So with this now we can find those tangent, sine, and cosine. So tan theta is 4/3. Then sine theta is 4/5. And cos theta is 3/5. Now, for quick reminder, we can develop an acronym that we can use to remember this quickly. So we can call this SOHCAHTOA. So we have this. Finally, we have the one we call TOA. Just this one. So we call this SOHCAHTOA. So what it means is the same thing we know. So what it's telling us, when you are dealing with sine, you know that sine is opposite over hypotenuse. So the O means opposite, the H is hypotenuse. Then this C means cosine. So when you are dealing with cosine, you know it is adjacent over hypotenuse. So the A is adjacent, the H is hypotenuse. And when you are dealing with tan, so T is tan, it is always opposite. So O is the opposite and A is the adjacent. So we always use this one in high school. So this gives us a quick reminder when we are dealing with trigonometry. So you can put this, copy this in your notebook, and we always recall it when we are solving this kind of problem. In this example, we are required to find the value of sine x plus cos x. But in order to do that, we first of all find sine x, find cos x before we do the addition. So we start with sine x now. So sine x, as we used to know, is opposite over hypotenuse. So opposite over hypotenuse. If you look at this now, the position of the angle has changed, unlike what we used to have before. So here we're having x now. So we're looking to the opposite of this angle. So if you watch carefully, you find out that this angle x now is facing this direction. So this angle x is facing that side, which has the unit 5. So the side is facing now is has the side to be 5 units. So this should be 5. Then the hypotenuse is the one facing the right angle, and it was always known as the longest side. So if you look at this now, the right angle is facing this side. So that side the right angle is facing is known as the hypotenuse, or also known as the longest side, and that gives us 13. So the next is to find cos x. Cos x, as we know, is adjacent over hypotenuse. Okay, so the adjacent should be 12. So that is the side that is not facing the angle. It is not also facing the right angle. So the adjacent should be 12 now. So we have this to be 12. And the hypotenuse again is the one facing the right angle, known as the longest side, which is 13. So we have this to be what? 12/13. Now with this, now we are now ready to find sine x cos x. So we can now say therefore now, the sine x plus cos x now will now give us, so this will be equal to, what is sine x? Sine x is 5/13. So we now write 5/13. So here I have 5/13 plus cos x. And what is cos x? Cos x is 12/13. So here we have plus 12/13. Okay, so this will now give us now, so the LCM is 13. So here should be 5 plus 12. And this should give us 17/13. So what we have gotten finally is that our sine x plus cos x is now equals to 17/13. And that's what we have. So this gives us 17/13. And that is equals to sine x cos x, which we expected to find from the example.